Hey Braden, how you been? Thanks for your good question. I just want to get back at you with a little explanation here. I can tell you're being very thoughtful about the trigonometry and understanding it well, given your question. So I actually agree with you. The hints that they gave are not necessarily the way that I would have thought about the explaining this question. So hopefully my explanation can help you a bit. So I've been thinking about, this is a cosine function, sort of in this format. Where we have A, B, C, and D, where A is the vertical stretch or shrink, which affects the amplitude, and hopefully you watch my other YouTube videos I put together. They're pretty quick. If you haven't, go check them out. And then B will do my horizontal stretches or shrinks, which affects the period. So A affects the amplitude. B affects the period, which is how long it takes for the graph to repeat itself like this, right? And then C would be the horizontal shift. Actually, I'm realizing, as we've done with the others, that should be a minus for C. And then D would be the vertical shifts. So this one is a little tricky because they put your D in the front. I probably would have put +7 if I were writing it. And then I knew that that would be shifted up 7. And it shifted to the right 2. And my A, my amplitude, well, it's a vertical reflection, but the amplitude is 7. And then the B is 2 pi over 20. And what you may have seen, well, like with our regular sine function or cosine function, cosine, which would start up here. For both of those, the period is, for it to repeat itself, is 2 pi, which makes sense because 2 pi is one rotation all the way around the circle. But because we're dividing by the B factor, right, it's got that reciprocal relationship, we could take the B and do 2 pi over B to find what the new period is. So what we're going to do is, and I've written that here, in this case, B is actually 2 pi over 20. It involves the 2 pi and the 20. So if I'm to do 2 pi over 2 pi over 20, well, I get a complex fraction. And that is the same as doing 2 pi times the reciprocal, which is nice because those cancel. So the period for this graph is actually 20 because the B is the only thing that's going to determine the period. So what I actually did here was I graphed this on Desmos so that you can have a nice visual of this. I just took the exact equation as it was given to you. You can see it is shifted up 7, so it's the midline. And the period here, you can see the points of intersection here. Let me get my highlighter. Bam, bam, bam. Well, the period it takes for us to repeat itself ends up being 20, right? From -3 to +17. But in the period, it actually hits the midline halfway through because it's got to go down, up, and then up, down. And then it repeats itself down, up, down. So it actually is going to be half of that, which will be 10, which was the answer that they recommended. It's going to pass that midline every 10 seconds. The explanation that they were giving was a little bit, it was talking about how the trig value is repeating itself based on the rotation by using an algebraic explanation. But hopefully my explanation that involved sort of the period and the graph helped as well. Also, for all these, Braden, if you like to just go and graph them on Desmos as an aid, I think that's a perfectly good way because these trig problems are getting quite tricky, and you'll probably end up, if you can do problems like these, you're very, very in even just the questions you're asking, the things you're thinking about, you'll be in great shape for pre-calc next year no matter what. So I want to now talk about this next problem that you posed and told me you're having questions about. So this problem had a similar structure here. So again, you're holding, or Kajal is holding a ruler in some wavy water. The depth of the water after she starts measuring is given by this sine function. So this one again is, it's been shifted up 50 units. Again, maybe I would preferably write it like this, but so the midline is at 50. So if I were just draw a rough sketch, the midline is up here at 50. Y equals 50 specifically. And it's been shifted to the, well, sine usually starts at the midline or 0, but this one's been shifted up, so it's going to start at 50. But it's been shifted to the left, so actually at negative 0.23 on the x, that's when it's going to be at 50. And sine, well, this has a negative first, so sine is going to go this way, and then this way, and then it'll keep repeating like this. So I don't know much else about it. Well, I could figure out the period based off pi, so actually that's easy, 2 pi over pi, like we did on the previous problem. The period is going to be 2. So that means it's going to hit here at well, just 2 more than the negative, so that'll be what, 1.77. I hope my math is right there. I'm pretty sure it is, because that'll be a period of 2. But when it's saying when, at what, the question they're asking is, when is the first time the depth of the waves is at its average value? So it's actually starting lower, this wave, because this is 0 here, right? So the first time is going to be right here. And Braden, you could probably use your deductive reasoning here to figure this out, but it's just going to be basically, instead of 1.77, it'll just be 0.77. And I believe it'll be 0.77 seconds. So again, I'm using a very different method than the one given to you here, but I kind of like thinking about it in terms of the transformation. So the period, how is that affected by, given the equation we have? How is the midline affected? Or in this case, that's the average depth. Or how is the amplitude affected, which actually doesn't matter. Whether this is going down 23 and up 23, this is still going to be the average value there. So the way the Khan Academy told you to think about it, I believe, was when is sine of, they told you to think about just this sine of this, right? Because when that's 0, that's the middle. It hasn't gone down or up. It'll be just at that 50, right? So what they wanted you to do was say, well, when sine of pi times t plus 0.23, set that equal to 0. And what you could actually think about is that the sine of 0 is 0. So by the ZPP, we wanted this whole thing to be 0. So let me go to my next page. So if I do pi times t plus 0.23 equals 0, well, actually, that's not right, because I don't want that just to equal 0. I want that to equal, when that's equal to a unit of pi, 0 or pi, then it's going to be, the sine of any, right, pi in radians is like 180. So when I end up dividing both sides by pi, I just get, really pi times any number. So just when this is, I'm taking some notes from this. Basically, they're just then saying that whenever t plus 0.23 is an integer or a whole number. It's kind of a tricky notation. I thought my explanation was better, but that's why it ended up hitting the midline at 0.77, because then 0.77 plus that would give you 1, right? And then we also saw it hit at 1.77 because that plus 23 gives you 2. And it also hit at negative 0.23 because that plus 0.23 gave us that 0. So that's why we ended up seeing those 3 spots here that we did. But I think thinking of it in terms of the transformations is better. That works better with my brain. Hopefully my explanation helped you too, Braden. Hope you're doing well. Much love to you and your fam. Hope everybody's staying healthy. Hopefully we can see each other sometime soon, or there'll be some sort of events to get everybody together at some point, because it's sad not being able to get together in person as a class. I know one day we'll all get together again soon. So be safe out there, and try to keep finding good ways, positive ways to grow and spend your time, which I'm sure you're doing. Much love.